Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good day to my panel. Thank you for being my panel for my presentation FYP1. Without further ado, I would like to introduce myself. My name is Siti Nurul Aliza binti Shaharudin, and today I'm going to present my final year project 1, which is CFD of bubble generation in co-flowing microfluidic device. My final year project was being conducted with the support and help from my supervisor, Dr. Elinadia binti Abdul Latif. These are the points that I will present and discuss in the next slide. The first slide with the project summary of the CFD of bubble generation in co-flowing microfluidic device. So, for the first point is about what is microfluidic device. The microfluidic device is a composed of channel, valve, or the mixer to control fluid in microscale channel size. This microfluidic is the system produce the fluid in bubble formation. This bubble is being produced by microfluidic device that must deal with multi-phase flow. This multi-phase flow consists of two phases that use two different fluids, which is continuous phase and dispersed phase. In order to become multi-phase flow, the two phases must be in immiscible liquid phase, which is the fluid cannot mix together to create emulsion between two different fluids such as water and oil, so that the bubble will produce. The bubble generation has been used in various applications, mostly in biological and chemistry applications, such as in drug delivery, tissue engineering, and DNA assays. In my project, one advantage of the bubble generation in science application is it can help to get monodisperse phase, which is in uniform size, and from that, this enables to do comparison and screening application. In my project, the co-flowing geometry channel design is being used that will be designed using CFD simulation to generate the bubble. The phase that will be used is oil and water as dispersed and continuous phase. The objective of this project is to get the monodisperse size, volume, also the frequency of the bubble formation using different viscosity of the water to produce oil bubble. This test will be done through the CFD simulation that using NC Fluent software. In this project, the co-flowing channel geometry has been used to achieve the objective. These co-flowing channels consist of two microchannels, which is largest channel and small channel. The small channel will locate in the middle of the largest channel. The project uses two fluid flow, which is water and oil. This water and oil is chosen because it is immiscible phase. The water will act as continuous phase and oil will act as dispersed phase. This co-flowing channel will generate the bubble in laminar flow because it is easy to control. The laminar flow is formed because of the low Reynolds number. The low Reynolds number is being get from the bubble that form in small length scale, which is in micron size. The parameter that been used were the viscosity of the water in order to produce oil bubble. The viscosity of the water will be used in three different values in order to produce the oil bubble. And from that, the size, volume, and the frequency of the oil bubble will be achieved and will be compared based on the three different value viscosity of the water. These are the two examples of the microfluidic device that have been used in biological and chemistry application. The figure 1 shows the microfluidic chip to test the fluid behavior. The second one is the PDMS using co-flowing channel. The PDMS was being created using mineral organic polymer that contain carbon and silicon. The PDMS structure contains of two microchannels, which is for the first part is the continuous phase and the second part is the dispersed phase. The continuous phase will flow. The continuous phase will flow and pinch off the oil phase into the droplet form when it meets at the end of the dispersed phase. The video shows the flow of the bubble formation based on the experimental study. The outer channel is the continuous phase and the middle channel is the dispersed phase that form the bubble. This continuous phase is being used to flow and pinch the dispersed phase to form the bubble. This bubble is formed because of the pressure and the shearing force of the continuous phase stream that makes the liquid interface rupture, and from that the bubble is produced. The picture below is the co-flowing working system. The next slide is the objective. The objective for this project were to develop a CFD model of multi-phase flow in microfluidic device with co-flowing design. The second one is to investigate the effect of different viscosity on the size, volume, and the frequency of the bubble formation. Based on the previous study, there is the lack of the investigating the effect of the continuous and dispersed phase viscosity on the size, volume, and the frequency of the generated bubble. So, this project is relevant to do in order to get the result. In this slide, I will reveal some of the literature review that I've been searched in order to get the information for my project. For the first literature review is about the computational study of droplet breakup in a trap channel configuration using volume of fluid method. In his study, the effect of the flow condition parameter and outer channel size on the droplet breakup mode, droplet generation frequency and size. In this study, they conduct the experiment in CFD simulation. The two different outer channel, which is wide and narrow channel, is being used to investigate the experiment. The phase they use is oil that acts the continuous phase, while the water acts as the dispersed phase. From the result, the size of the droplet is formed. The small size of the droplet is produced by the narrow channel, and the larger size of the droplet is formed by the wide channel. The frequency increased in a narrow channel because the pressure of the continuous phase stream in the confinement region is bigger compared to the larger model, which lead to easily and quickly pinch off the thread of oil to form the droplet. The second literature review is a generating microbubble in a co-flowing microfluidic device. In this study, they study on the microbubble generation mechanism in co-flowing microfluidic device. From this literature review, they use a gas which is propane, butane, and air as the dispersed phase, and they use CDSTS pH solution as the continuous phase. They use the flow rate as the parameter to define the size of the bubble. This was conducted in the experimental method, which they use two syringe pump and heat chamber to detect the size of the microbubble. For the next literature review is a numerical and experimental study of oil in water droplet formation in a co-flowing capillary device. In this study, they studied generating the size of the microbubble using co-flowing microfluidic device. They used the two methods, which is CFD simulation and experimental study. The result they used the higher mean velocity and the viscosity of the continuous induced the higher drag form to the smaller droplet. For the last literature review is the gross characteristic of the microbubble in a co-flowing liquid and microfluidic chip. In his study, they studied to investigate the effect of the liquid flow rate, gas pressure, gas channel width, and the concentration of the polyvinyl alcohol PVA solution on microbubble growth process to help in the volume and generation frequency. They use a PDMS microfluidic chips as the method to get the result. The phase they use is a nitrogen gas and the polyvinyl alcohol as the continuous phase. On this methodology slides, I will explain further about the procedure that will be taken during my project. In this slide, I will explain the step on how my project will be created using CFD simulation, which is ANSYS software. There are 7 steps that I have to go through in order to get the result. The first step is I have to determine the important parameter, which is viscosity, flow rate, inlet velocity, inlet pressure used, and also the geometry size of the co-flowing channel. The viscosity is the main parameter that I have to investigate in order to get the size of the bubble, the volume of the bubble, and the frequency of the bubble. This viscosity, I use the different 3 values of the water to investigate. The flow rate, the inlet velocity, the inlet pressure used, and also the geometry of the size between the both water and oil phase is the constant. For the next step is I have to design a 3D channel co-flowing model using the geometry obtained from the literature review of the microfluidic device using CFD and ANSYS software. For the next, I will develop a quadratic mesh using ANSYS Fluid. This quadratic mesh is used to simulate the geometry from the complex to a simple element that can be used as a discrete local approximation of the large domain of the co-flowing microfluidic device. The quadratic mesh is used because it gives most accurate to the effects of the surface tension. Next, I will apply the boundary condition and inlet velocity of both phases with no viscous stress, and I will also apply the boundary condition at the both outlet pressure with the no slip boundary condition, and I will also apply the physical properties of the phases. Next, I have to validate the 3D channel of the co-flowing modeling using volume of fluid (VOF) method in ANSYS Fluid software to get the result of the size, the frequency, and the volume of the bubble formation. For the next, I will run the CFD simulation for the 3D co-flowing channel to get the results. The data that I have get is used to investigate my result. This slide is about the preliminary findings that have been get from the previous study. The geometry of the co-flowing channel they use is an experimental method to investigate the result of the bubble formation. In my project, I will be used the geometry of the co-flowing channel based on their experimental method in CFD simulation method. The model that I will use for the co-flowing channel is the PDMS model that I have get from the previous study. These are the schematic diagram of the 2D co-flowing microfluidic device geometry that I will use in my CFD simulation method. The model that I use in co-flowing microfluidic channel is I use the PDMS model as I been get from the previous study. These are the parameters that I will use in my project for the CFD simulation of the bubble generation in co-flowing microfluidic device. All the parameter is the constant value except for the viscosity, as I use this viscosity as the main parameter that I will investigate to get the result of the size of the bubble, volume, and the frequency of the bubble formation. This parameter I get from the previous article and journal. In order to get the result that meets my objective, is I have to use the method of VOF method in CFD simulation using ANSYS Fluid software. For the material, I've been used oil and water as the continuous phase and disperse phase. The mesh geometry of the co-flowing microfluidic device is used a quadratic mesh in ANSYS Fluid software. This mesh geometry is used to simulate from complex geometry to simple element that being used as discrete local approximation of the large domain of the co-flowing microfluidic device. The size, the frequency, and the volume of the bubble formation will be gauged based on the different viscosity of the water in produced oil bubble. The volume, the frequency increase because of the high viscosity used in the water phase. The size will decrease when the viscosity is increased. These are the methods that I will use in my project to get the result. That's all for my presentation regarding on the CFD of bubble generation in co-flowing microfluidic device. I hope all my explanation will understand you more about this project. Thank you and Assalamualaikum warahmatullahi wabarakatuh.